Okay, Math 1 1.8 Inequality Notes. So I wrote some notes here, and I don't know if you actually need to copy them down. Some of it might be review for you, but I'm going to read through it here. So if we have written x is less than 5, talking about this spot right there, x is less than 5, you read that as less than, that's what I have written there. And that means that x is smaller than 5, right? Less than, smaller than, kind of the same idea. Next up, we have x is less than or equal to. That little line underneath it, that means or equal to. So this means that x is smaller than 6, or it could be 6, right? So instead of saying that x equals a number, we're saying that x has a range of numbers it could be in. So for this guy here, let me highlight. For that highlighted portion there, x could be 4, x could be 3, x could be negative 100, x could be 6, right? It has a large range of what it could be, right? Okay, next up, x is greater than 7, means x is bigger than 7. So x could be 8, x could be 9, x could not be 7 because it's not equal to, it's just greater than, okay? And then last up, x is greater than or equal to 9. That means that x is 9, 10, 11, 9 and a half, 9 and a quarter, one of those, okay? Now, if we were to graph these, and the graphing might actually be new for you guys, I'm not sure. So x is less than 5, you make a little number line, and we put 5 on it. We'll put 6, and we'll put 4 on it. We're going to put a dot on 5 because that's the number that x is less than. So I'm going to put an open circle, right? Open circle, okay? An open circle means that it comes right up to 5, but it's not at 5. And it says x is less than 5, so that could be like 4 or 3. And so that means that we're going to shade over here, okay? And by graphing it and shading it, we mean that x could be anywhere in that shaded region. All right, I'm just going to go all the way down, and I'm going to do x is greater than or equal to 9. So if I draw a number line again, and I've got 9, and I'll put 8, and I'll put 10 on here. It's greater than or equal to, so I'm going to put a circle on 9, but I'm going to fill it in. And the filling it in means, well, it could be 9 also. So it says x is greater than or equal to 9, so 10 would work in that, right? Because it's bigger than 9. So I'm going to shade on the side that has 10. A lot of the times when you do these problems, it's convenient or it's easy, it helps. If you think about a number that is bigger or smaller than, and just ask yourself, well, does this make sense? So like for this one that we just did, I said, well, does 10 make sense? Well, 10 is bigger than 9, so yes, that makes sense. So I'm going to make sure that I shade and it includes the 10. Okay, let's start off on number 2. Draw a graph for each inequality. And we already have a nice little number line here. So it says x is less than negative 1. So we do not have a line underneath it like that, okay? That means that we can just do an open circle on the number, okay? Let me change to a brighter color. So we're open circle on negative 1. And now I want to decide which side do I shade on. A lot of the time it's really easy to use 0. So I'm going to say, well, 0 is less than negative 1. Is that true? And the answer is no. So I do not shade with the 0. I shade away from 0, so I know I shade over here. Okay? You could have picked any other number. The 0 is not special in this case. You just pick anything. 0, I think, is easy whenever they get a little bit more complex, because if you multiply things by 0, it zeroes it out. It makes it a little bit easier. All right, number 3. N is less than negative 2. So same idea, we do not have a line underneath it. So we can just do an open circle on negative 2. And then we'll check again. We'll check this 0. We'll say, well, is 0 less than negative 2? And the answer is no. 0 is not less than negative 2. So we shade away from the 0. All right. Oh, I left a lot of space there. Number 4, solve each inequality and graph its solution. So this one makes it a little bit different. You have to actually do some algebra before you can graph it. So whenever you solve them, you need to pretty well just treat it as if it's an equal sign here, okay? The only time that you can't treat it as if it's an equal sign is if you divide or you multiply by a negative number on both sides. And I think there's going to be a problem like that later on, and I'll show you what I mean then. So for here, I'm going to pretend like I have negative 11 equals x over 3, right? If you get really uncomfortable, you can always write it as an equal sign, but I'm gonna leave it as the greater than for now. That way we don't get confused. So I'm going to multiply both sides by 3, and I get negative 33 is greater than or equal to x, right? So now I just go off of this just like I did numbers 1 and 2. 1, 2, and 3 maybe? Or 2 and 3, because the number 1 was the notes. All right, so negative 33, where is that going to be? That's going to be right there. So it says negative 33 is bigger than x, right? That's another way to read that. So let's see if x, let's just plug in 0 just to see. 0 would be somewhere over here, right? So negative 33 is bigger than 0. Well, that's not true. Negative 33 is smaller than 0. And just a side note, I'm sure whenever we were in elementary school, you guys learned that the alligator eats the bigger number. That's still true here, right? The alligator here would want to eat the bigger number. He wouldn't want a small meal, he'd want a big meal. Negative 33 is a much smaller meal than 0, right? So this is not true, so we're going to shade away from 0. Alrighty. Number 5. Now, say we have n minus 8 is greater than or equal to negative 6. Well, to get that by itself, I'm going to have to add 8 to both sides, right? So I'm going to have n is greater than or equal to, well, 8 minus 6 is 2. So now I have a dot on 2, and it's going to be a filled in dot because it's a greater than or equal to, right? So let's plug something in and just see how it works. We'll plug in our 0. So we're going to have 0 is greater than or equal to 2. And we want to say, is that true? Is 0 bigger than 2? And the answer is no. So we have to shade away from the 0. Okay. Number 6. Good. We're going to divide by a negative in this one. So first, let me just rewrite it down here. Negative 9 minus 9p is greater than or equal to 63. To start off, let's add 9 to both sides. So we'll get negative 9p is greater than or equal to, what's that going to be, 60 or 72? 72. Now, we have to get p by itself. We're going to divide both sides by negative 9, right? Now, here's the trick right here. If you multiply or divide, here, let me write it out. If you multiply or divide by negative number, flip the inequality. Okay. Now what I mean there is here's my inequality. It's going to end up being like this. Okay. The alligator is going to eat the other side. So we still have our p on the left, and 72 divided by negative 9, I'm believing is negative 8. Okay. So this is a big deal here. What I wrote here. You need to remember that. That's a very common mistake. So p is less than or equal to negative 8. So I'm going to have a circle on negative 8. It's going to be a closed circle because it has the equal to. We'll see if 0 works. If we had 0 is less than or equal to negative 8, Well, that doesn't make sense because 0 is bigger than negative 8. So this is not true. So 0 is over here, right? So I'm going to have to shade away from it. Okie dokie. Number 7. Now, whenever you have a complex fraction or a big fraction like this, sometimes it's helpful to put parentheses around it just to remind you what you're doing. So I'm going to multiply by 2 on both sides so that I can get rid of those parentheses. And I'm going to have negative 26 is less than a minus 10. I'm going to add 10 to both sides. And I get negative 16 is less than a. I didn't have to multiply or divide by a negative number in this problem, so I don't have to flip any signs. Now to graph it, I need to have an open circle on negative 16. It's open because there's not a line underneath there. And it says negative 16 is less than a. So that means, so 0 would be over here, right? Let's just plug in 0. Negative 16 is less than 0. Well, is that true? Yeah, that is true. So we're going to shade over here. All right. Number 8. All right, there's 2 ways that we could start off this problem. The easier way and the harder way. I think I'm going to do the well, kind of the harder way, but it ends up saving work. So I'm just going to copy it down here. Negative 7, 4p plus 8 is greater than or equal to e4, right? Okay. What I'm going to do here is I'm going to divide both sides by negative 7. You could have distributed in that negative 7, but then you just have to divide by something later on. So I'm just going to divide by it right now. So on the left, I'm going to have 4p plus 8 is greater than or equal to, and what is 84 divided by 7? 84 divided by 7, oops, divided by 7, 12, and it's going to be a negative 12. Oops. Did you catch my mistake? We divided by a negative number, so our sign here has to flip. Our inequality has to flip. Okay? Don't forget to do that. We're going to subtract 8 from both sides, and we get 4p is less than or equal to negative 20. Divide by 4 on both sides, and we get p is less than or equal to negative 5. So we'll put a closed dot on negative 5. Okay. And 0 would be over here, so we'll say, well, 0 is less than or equal to negative 5. So 0 is smaller than negative 5. That's not true. So we're going to shade away from 0. All right, number 9. Again, I'm going to start off by dividing by 7. So I'll divide both sides by 7, and I'm going to have negative 5 minus 3r is greater than or equal to, and I have 133 divided by 7, oops, divided by 7, and I have 19. Now, notice that I did not flip the inequality because I did not divide by a negative number. I'm going to add 5 to both sides. I've got negative 3r is greater than or equal to, 19 and 5 is 24, right? Now I need to divide by negative 3 on both sides. Let me change my color into a orange. Divide by negative 3 on both sides, and I have r. And 24 divided by 3, what is that? 24 divided by 3, oh, that's 8. And it's going to be a negative 8, right? Because I divided by negative 3. Oh, I divided by negative 3. I need to flip my inequality, right? So now let's graph this. I've got a closed dot on negative 8. It's a closed dot because I have this line right there. And let's pick a different number, just because I don't want to always use 0. I don't want you to think that 0 is special. Let's pick negative 10. So negative 10 is less than negative 8, less than or equal to negative 8. Is that true? Is negative 10 smaller than negative 8? Well, yeah, negative 10 is smaller than negative 8. That means we're in a shade with negative 10, or towards negative 10. All right, that's it.